Ladies and gentlemen, welcome to our webinar this morning again. Thank you very much for participating and joining us. We are going to take 1 hour this morning to discuss about the international standard for digitalization. That was a request from many of you from our last webinars on digital technology over the energy industry. So today we are really going to be quite specific on the way about standards, because it was a broad question. Just before going and jumping on the topic directly, just few announcements regarding the webinar and how it is going to work. First, the information about our next webinar. It will take place on the 17th of June on 2 p.m. This time it will be on the afternoon, so people from US can also join us more comfortable. And we will deal about hydrogen. We'll discuss the topic and discuss what are the type of plants, the type of technology being developed on this market. And we also look at the market outlooks over, let's say, tomorrow, let's say a period span of 5 years, but also the vision on 10 and 20 years. So if you want to join this webinar, you have the invitation directly in the discussion of this webinar, and you can download the invitation to be sure not to miss the event. In the meantime, I invite you to follow our LinkedIn page, because we'll post the video of this webinar directly to our page. So if you want to see them again or even an introduction to it, you can have it there directly. In the meantime, you can also shoot me an email at the address guillemjean, which is also in the discussion, to receive the slide that we are going to use today. If you have any question, of course, during this webinar, you have a Q&A section in the tool of the team, so you can ask us any question. We'll take all the questions at the end, so we don't have to run off on the time, and we are sure to be on time. We can jump directly on the agenda. You are going to see that the agenda today is quite broad. First, of course, we'll make a small introduction about ourselves, about the topic itself. Then we will discuss about the project database, where we are taking information about all this digitalization process. Then we'll start really by the basic, talking about the history of Industry 4.0, then talking about digitalization all over the world, and then we'll go more in the detail about the standardization, how it came up, how it works, and then we'll go, of course, in the details about the standardization bodies, but also the list of standards that you have to be aware if you want to work in digital. So buckle up, and I'm going to leave the floor to Jean-Charles, who is going to do the first part of this introduction. So Jean-Charles, the floor is yours. You can start.
Thank you, Jean. Thank you, Jean, for this introduction, and thank you, everybody, for joining this fourth webinar. And we are very pleased to see more and more people joining those webinars, so that encourages us to continue in this way around those key topics, which may be about technologies, market development, or digitization. So for people who are not familiar with our company, you will understand that we are a family company that I created in 2012 after many years as vice president of ABB in charge of the oil and gas and petrochemical market. And with two activities. One is business development, market analysis, with a database called Project Smart Explorer, from which we extract data to provide you with market outlooks, trends, and so on, and a digitization solution that we develop for all industry, not only oil and gas, but aerospace, nuclear, transportation, and so on. So I go very quickly on that, but you understand from our profile that we are a very typical profile, completing each other's on different industries, and it could be manufacturers or operators in different sectors. So to go straight to the topic, we work on this topic for many years. We are publishing papers in different conferences and organizations. Many of them are related to PCIC, the Petroleum and Chemical Industry Committee, which is sitting in USA, which is sitting in Europe, which is sitting in Middle East as well, and many other conferences, including Hannover Fair and some other events. So in this presentation, behind this title, in fact, you can find a link to those presentations if you are interested in this topic. So short introduction about the database that we use as a source of information. We trace permanently 1,000 projects in the world that we consider as the most active, so covering oil and gas, petrochemical, and energy covering decarbonation and renewables like solar, windmill, hydrogens, carbon capture, and so on. So all sides of this energy market. Regarding Industry 4.0, we have structured the database around Industry 4.0 for a simple reason that Industry 4.0 is the only architecture being structured based on international standards. We'll come back on that in more details in some slides, but the basic one is OSI layer. As you may know, if you are automation engineers, OSI layers is the acronym of anagram, sorry, of ISO, and that's quite a famous and well-known structure in automation to treat data and all automation system in companies. But of course, it's not enough, and that's where this architecture industry model is interesting, because it added the idea of the IEC standard 62890 to cover the whole life cycle of the installation to monitor the data and the status of an object. It can be a component, it can be a plant, it can be whatever thing. And having done that to cover the whole data during the life cycle of this object, of this thing, then you need to transfer the data from where it is to the connected world in order to transfer this data and share it with other companies. And that's where this IEC standard 62264 and 61512 are very helpful to define the hierarchy level through which you can escalate the data in order to come from the ground floor to the connected world and share this data with whoever is supposed to get access to this data. So once this architecture is in place, based on those standards, we have defined 8 packages to monitor the market on this digitalization. It starts, of course, with data capture. It continues with connectivity and data formatting to be able to share those data. Then you need an operating data system. And then from there, you are able to build up the asset digital twin or the process digital twin. Unfortunately, it's not enough. You also need a cyber security to protect those information. And when you want to implement in practice those information, you need the augmented operator. And then that's where nearly the loop is about. But you also need the last layer, which is about health, safety and security and environment aspect to cover as well, to make sure that the whole system is acceptable and physically implementable on site. So that's the 8 package that we are tracing in energy market, and which help us to analyze the market and how it does evolve. And those packages are also based on international standards, which is the topic of today. So now, a short reminder regarding the history of Industry 4.0 to make the link with the standards. First revolution, as you may know, come from the steam. It was at the end of the 18th century. And then you had the second revolution with electricity at the end of the 19th century. And then you have the third one in the middle of the 20th century with the introduction of the computer on machine and, let's say, the computerization of the industry more generally. The fourth revolution was called that way to make a clear difference between computerization of the industry and digitization. Digitization means that you connect your manufacturing process to other companies. That's what we also call the extended enterprise. All right, so it's a big difference between putting computers on machine or using a very sophisticated software for whatever purpose, which is still on the third industrial revolution, and connecting your tool, your system, your computer, your PC, your machine, your things with third parties outside of your company, because that's where you change totally the universe and many questions comes up, and that's where this fourth revolution is about. So historically, the story started in 2006. In fact, at the time, Germany was exporting massively to China, especially. And of course, German were wondering after a certain time, there was some kind of risk that all those machines being exported to China would generate indirect competition to their own industry after some years. And so they were wondering how to preserve over the years the made in Germany competitiveness in front of low-cost countries using most modern machine and completely new plants based on the German technology. So that was a starting point of this story. The second point came in 2008 with the financial crisis, where in fact everyone could realize that countries with a high percentage of industry were much better resilient to economic crises than any other countries where the economy was more relying on services. So that was also very important accelerators of this conviction to enforce the industry sector in Germany. And the solution pops up in 2010, when the German industry rediscovered the cyber physical system. In fact, the German had invented the cyber physical system during the Second World War, has many other things, as you know, as they were used on the aircraft, the war aircraft, to monitor the behavior of the airplane during air fight. And that was the idea that the German industry thought that, okay, we could reuse that and extend that at large scale for all equipment so that we could put some intelligence out of the things and physical things. Then this program came out officially at the Hanover Fair in 2014, well promoted by Angela Merkel herself, and to explain how this Industry 4.0 would be the next revolution of the industry overall. And a couple of years later, in 2017, this concept of Industry 4.0 has been globally recognized by Amber Summit of the G20 in July 2017. So that's a brief history to understand how this story started and how it had expanded over the world through this different key step. So if we look where we stand and how the world has reacted on this, Europe started to include this digitalization program in this program Horizon 2020 that you may have heard yourself, with 80 billion allocated to this program. In France, it has been called originally Usine du Futur, then Industrie du Futur, which is more related to Industry 3.0. So is more concentrated on the computerization of the industry more than the digitalization itself. But step by step, it comes into the digitalization now. Germany started in 2010, as we mentioned earlier. Italy decided to copy-paste the German process right away and called it Industria 4.0, and they put in place partnership with German industry to align and adopt all their standards right away. UK created a program called Future of Manufacturing, but with the Brexit and many of the turbulence coming into the UK, it's a little bit difficult to say where it stands today. What is sure that UK has a number of solution providers proposing advanced solution for digitization. That's at least where they are clearly well recognized and active at this moment. China, originally China created a program they called Smart Automation 2.0 in response to the German initiative. But finally, they adopted the Industry 4.0, and you may have noticed that they acquired the German KUKA robot manufacturer, in order to really officially integrate Industry 4.0 in their industry. India proposed another program, a little bit different, called Make It in India, which is more concentrated on the software. But the idea was to deploy digital corridor to speed up the connectivity between industry across India, which is a country, but which is nearly as large as a continent, as you know. It's a well-advanced digital country in many aspects, but it's missing the infrastructure, and that's where India is putting the effort to put in place this infrastructure for connecting all industry across India. Japan developed its own program in response to the Germans. They called it Industry Value Chain Initiative, IVI. It was their own architecture at the beginning, but then after 2 years, 3 years, we'll see an example. They aligned or they paid attention to make sure that their own architecture would be complying and align at a certain point with the German Industry 4.0. Korean had a different response, total different style, not architecture, not technology, but more from financial point of view and business model. They call that a creative economy. And they boost, let's say, or startup system to develop their own South Korean engine, as they called it. So it's more on the financial and motivation aspect with financial incentive and so on, more than on technology side. And today we'll see that South Korean companies are using international standards supporting Industry 4.0. In North America, it has been a bit complicated. The first response was to create what they call Industry Renaissance Program. It was driven by MIT, GE, Dow Chemical, Honeywell, and many other industries well known in the USA. This initiative never took off really, never delivered really anything concrete. Then they had a program called Internet of Things, but it's about the same. Things are started to move really with the OPC Foundation, which was driven by Microsoft. We saw that at the end of the day, this OPC Foundation has aligned its architecture and standards on Industry 4.0, so that today USA has also aligned its own industry architecture and standards in Industry 4.0. So this overview here of the world is just to show how, starting from different local initiatives, at the end of the day, more or less all the countries have aligned on this Industry 4.0 architecture, precisely because it relies on international standards. And that was a key point of this initiative. So some words about cyber physical system, because some people may not be familiar with that, and that's part of the key to understand the standards and the RAMI 4.0, which is this reference architecture I was mentioning earlier. Cyber physical system is a quite interesting wording, which in fact indicate that you put some sensors on physical equipment, and from which through software and connectivity solution, you can capture data out of this physical system. And that's where you create a cyber physical system, because you are able to transfer or to convert, let's say, a physical product into a model which is completely digital, and then you can see, of course, that the volume of data that you can extract from this physical object or thing will increase along the life of this object. It will start, of course, from the design phase. It will continue during the production of this object, then the engineering, the complete execution, and the services, and afterwards the use of it. So you have the complete digital twin life cycle here, which is built up, and for which each industry will have its own way to proceed, because of course each industry is different and has its own constraints. But anyway, at the end of the day, the key point is that whatever is the industry, all this industry must be able to communicate together. And that's where the challenge is to put in place an architecture which will be able to exchange data, whatever is the use of system of each operator. And that's where this reference architecture model, Industry 4.0 or RAMI 4.0 comes here, where between two objects, one sensor on the left and one machine on the right, you have in the middle this three-dimension architecture we saw earlier, where you have again this OSI layers here, which is an existing structure in automation, as we mentioned that, combined together with two IEC standards to have a complete matrix and architecture capable to capture data at the ground floor and to transfer this data through internet to any kind of third party adopting the same system, so that the information can go back and forth between two partners or more through internet, through this architecture, as long, of course, that each company is referring to the same standards in its own architecture. And that's where it's so important that people adopt a solution or architecture referring to the same standards. Just one word on the OSI layers. I mean, just to remind that OSI layers is not something new again. It's for automation engineers, something which is absolutely well known for decades, and which is the base of this architecture, Industry 4.0, and on which, again, had been completed by other international standards. One view on the Japan model, which was interesting. We are not going to describe, of course, this Japanese model here called IVRA, but just to show that when the Japanese developed their own architecture, they paid attention to make sure that this architecture, if being used by Japanese company, would comply and align somewhere with the German architecture, RAMI 4.0. So just to show how much all the countries who have developed their own architecture at the end of the day pay attention to make sure to align with this Industry 4.0, and the same with the OPC Foundation here, driven by Microsoft Windows ecosystem, where then it was published an IEC standards called IEC 62541, which describe this open platform communication unified architecture, the OPC UA, which is aligned with Industry 4.0 to ensure the interoperability on the system in the US, for example, or at least for companies using US reference standards and European companies using European standards. Regarding the standardization bodies, then I will leave the presentation to Jean, if you want to continue here.
Yes, so let me just take the hand on the presentation itself. Up, I'm going to deactivate your presentation. Up, if I can, because it's not sure if it's working. Well, anyhow, Jean-Charles, you will lead the slide, and I'll be doing the talking then. No, first, let's say break into the presentation. Again, if you want to ask your question, you can go to the Q&A section of the tool and ask your question. We'll answer all of them at the end of the presentation. As Jean-Charles was saying in the first part of this webinar, of course, this Industry 4.0 has a long history into it. You see, it's a development, it's alive, people are working on it, and he has a framework. Now, here we are going to talk about those standardization body. Of course, those bodies have, let's say, a clear understanding and international representation. The first topic here to talk, and the two main organizations we are going to discuss are, of course, the ISO and the IEC, which are the first provider of standard for digitalization. We'll go in more detail later on, but the first key message here is to say those standards for digitalization exist. We see still today many organizations around the world saying, okay, we are going to make an initiative to develop standards for the digitalization, blah, blah, blah. No, the first here key topic is that nobody waited for them. Standards are already in place, they're already discussed. Those standards are open and international. Industry 4.0 is, let's say, an umbrella on top of this to put the tag to say, okay, those standards are used by the digitization. And it covers a whole scope, really going from the system interoperability to the innovation to the cyber security. If we go to the next slide to discuss about the ISO, what is pretty important is that the ISO stand and the story behind is it stands for the International Standard Organization. So that's really their job to make standards. Many of you knows what ISO or at least have heard about ISO, but in the history, in fact, ISO comes from the Greek word isos, which means equal. And ISO was created after the war, first in London, but now in Geneva, to remake those standards. Today, they have a portfolio of 24,000 standards, which cover a broad scope, going really from technical topics like digital, electricity, but also economics, environment topics, social, but also management. They are representing around 168 countries, and which are part of the ISO. And in fact, each country has a member as part of the ISO committee. And then under it, people working on the subject are called technical committees. Those technical committees are almost 800. They are all specified with experts in their field. And you have an expert which belong the standard itself. And under it, you have, let's say, a country committee, which is the underlayer working in collaboration. If we look at the process to build a standard, you have, let's say, a technical committee which is responsible for the standard globally, and you have under it a country technical committee, which are the one making proposition about the update of the standard or new standards, which are making correction on existing standards. On top of that, let's say each country is proposing a new addition to standard, and this technical committee globally responsible for the standard has a mission, let's say, to grab and to consolidate all those requests from country technical committee, and then throw them back, let's say, to the field for update and comment and correction. And as soon as they have a clear validation, the global technical committee take, let's say, the updated version of the standard and make an official publication of the new standard. So you see, it's a two-level, let's say, organization where people propose and then people answer, correct. So it's really a scientific approach, like we are used to know for research and R&D, and it's quite a double validation as well. So you see those ISO standards are always maintained and always update. If now we go to the IEC organization, here it stands for International Electrotechnical Commission. It was created even earlier, again in London. The organization is a little bit the same, to be honest. What is really different is the scope of application of those people, because the IEC really tried to focus on electrical problematic, security, electronics, automation, and as well start to be also on digital technology. But the working is a little bit the same. So now we are going to jump on the topic of standards itself, and we are going to list those, and we are going also to discuss first the link between Industry 4.0 and those international standards, because we have been talking a lot about Industry 4.0. Here is the organization. As mentioned by Jean-Charles, you have understood that Industry 4.0 was kind of the umbrella for those standards, because many standards exist around the world. Many are concerned by the digital, many are not. And in fact, the German created what they call platform Industry 4.0 to say, okay, this is the umbrella of standards that we need to address to talk about digital, and that's the one we need to maintain. Under this organization, of course, you have a collaboration for the digital transformation with the Standardization Council Industry 4.0 that I'm going to explain in a minute, and what we call Lab Network Industry 4.0, which are, let's say, all the people doing research with university, with R&D company, to say, okay, today the standards are here, but where do we need to push them to be adapted to the next generation of new technology? So you see, this is, let's say, a trio working on those topics. Of course, everything in there is open, so you can be sure that you can participate first, but you can be sure it's well maintained and well updated. If we go to the next slide, really on the standardization council industry, let's say it's a collaborative community composed of, let's say, founding members. Here you have the flag telling you like China, France, Germany, Italy, Japan, Korea, and US were really the founding father of this standardization council. Of course, Germany was a little bit the leader of this, but no, everybody is participating very well in the concept. And the idea of this community is to say, okay, we need to connect all the industry communities all around the world to be sure that we can interact between each other. We have a common interest in developing those standards, of course, and we can build up co-partnership to be sure that a machine coming from Germany will work and communicate with a machine coming from Italy and one from Japan and US as well. So that's really, let's say, the collaborative loop that is, let's say, the umbrella of this platform, and this Industry 4.0 tag, which is, let's say, an umbrella of standard working for the digital industry. So on the next slide here, you have the table of, let's say, the main standard that you need to know about digitalization. So you see it's a lot of code. We'll go in more details with just few bullet points on the standard, but the idea behind is to say, okay, you have many standards existing in the world. Some may address the topic, some may not address completely some topic. So here we really try to put, let's say, the main one. You have many more existing for digital, and here you have also the topic to discuss about it. The first one is, of course, functional safety, and you see the standards applying there are either IEC or ISO. It depends. The fact that the digital, of course, transition is an evolution also of the electricity and the automation is quite natural, and that's why we find a lot of standards just coming from the EIC community, because they were the first one to be facing, let's say, the problem of working on digital technology and new technology. Then if we go here, it's the list. I would say I would let you go through it, but then we will go in more details to each topic of this list. So starting by the next line on functional safety, we are going to discuss, yes, it's coming, the EIC 61511. Here it's about safety instrumentation. Of course, and the following one is really safety of machinery. Here the idea is to say, you know this common phrase to say data is the new oil, and the idea behind it is to say, okay, we need to focus on the first layer, which is the data capture. And here, if we talk about instrumentation, it's not randomly, it's because having a safe data capture through the instrument is really, let's say, the first building step of any digitization, because you need those data to build up value. And of course, that's why those standards are quite important and are quite, let's say, evolved and updated. I would not say on a daily basis, but every 3 months you have an update or a correction done to it, because the application are going and evolving very, very fast. And here you see the idea is really to say, okay, it applies to everything. It could be electrical, electronics, also automation. But the idea is really to have, let's say, a common understanding on how to capture those data. Okay, the idea is to make it safe as well and to make it common. If we go to the next slide, here it's a little bit also, let's say, a standardization about, let's say, the people. If you want people to collaborate from all the country, but across companies and stuff like that, you need to be really well aligned on your wording. It's quite important, and we see many problematic coming from collaboration, especially in digital, coming from miswording. And we are on new technology, so sometimes we don't have, let's say, the full comprehension of the technology behind, but it's really important to have a common wording. And these standards are here for that. The IEC 61360 and the ISO one are really to say, okay, we need to have a common, let's say, portfolio of words to be able to define different things. The first thing to define are the type of data, of course, but also the domain, the concept, and also the system to be applied, not only in automation, but also in digital. And those wording are quite, let's say, vital to maintain a good communication between people working on the subject. If we go to the next slide, it's about communication again. but it's not communication between people, it's communication between objects. As we were saying, the fourth industrial revolution is about connecting objects together. And of course, you cannot do it just, okay, waking up in the morning, say, okay, I'm going to send the information in this format, blah, blah, blah. No, it doesn't work this way. If you want to be able to make a component from Siemens communicate with a component from ABB with a component of General Electric, you need to be aligned. Those standards are here for that. And here the idea is to have a common ground of communication between objects, between IoT. And you have two main standards applying to that. You have the first one, which is really about the network, how you build a network, what are the families of protocol you can use to make your transfer. The idea of the standard is not to say, okay, you have to use this one. It's really open. It's not to say, oh, no, you have to use LoRa or you have to use Wi-Fi. No, it's really open. It's just to say, okay, if you are using Wi-Fi, you have to do it in those conditions. If you are using LoRa, you have to do it in those conditions. Same story with the second standard, which is really coming from the OPC UA that Jean-Charles has been introducing already. The idea is really to have this common shell about captors to say, okay, if you want to discuss with each other, if your, let's say, captor is not directly linked and available to work in the standard, you can have another layer, a shell above the captor, which will make the translation to be able to work on those new standards. So it can be applied to, let's say, brand new greenfield application, but you can also use the standard to brownfield and to digitalize old plant. The next slide is about the interface. Of course, it's quite obvious to discuss, let's say, two instruments together or two captors, but then you have to talk to the machine, then to the next machine in line, to the next process line, then to the next plant and stuff like that. Of course, you cannot do it with only one protocol for everyone. You have to make interface, you have to centralize information, then to pass those information to anyone, and you have to keep also kind of a process by yourself to be able to keep your device and put the shell in your architecture. So here, the idea of those two standards of interface is really to have, let's say, a control over your process, to say this is the way we have to build up the information from really the shop floor to the plant floor to the cloud. And this is the way we need to interface our device on the field to be able to build up value from this information. So of course, those are really complex, but it's really those vertical, let's say, protocol that you need to put in place to be able to really, let's say, agglomerate value and try to, for example, if you want to make machine learning, stuff like that, you really need to be put in place to be able to agglomerate those information. Going to the next slide here, it's less obvious because it's less in the operation of the plant itself, but here the digitalization also has standard for the engineering, because we talk a lot about digital technology for the plant in operation, but of course digital technology also helps us to build plant, to do the design and the engineering. Here you have, let's say, a list of standards that help you to characterize each piece of equipment, or you exchange data about those equipment at the engineering phase. So you know how they are going to talk together, you know how you are going to make your design, your engineering phase, and that's where you are going to control really the evaluation of your plant. Talking, for example, about digital twin, you know, the digital twin does not start really at the operation phase. It starts really from the ideation, from the design phase, follows and evolves at the engineering, and then goes to operation until decommissioning. So that's where you find the let's say the architecture to put in place to be able to make your digital twin evolve through those project phase. And here you have a few examples of standards that apply to it. Of course, you have other standards which can be really sometimes technical, going to the definition of a bolt, for example, to go really deep down in the value chain. Going to the next slide, here the idea is to say what is digital, what is not. You have two standards, IEC, of course, again, which is say what is a digital factory, because sometimes there is not a clear, let's say, border between let's say robotization and digital. Of course, it's sometimes a bit tricky and a bit, you have shades on both sides to say, okay, this is digital and this could be robotization. Here, those standards are really to say, okay, this is automation, for example, and then the automation, when you start to have this level of intelligence added to it or application on top of it, you start to be in the digital world. And of course, here the idea of those two standards is to say, okay, this is how you describe your automation process, and this is how you describe your digital process. And those two has to be handled quite separately, to be honest, because automation process is really a control process, while digital can be, let's say, back-end or scenariization process, where you can be not only active but also passive to make a lot of learning and capitalize a lot on it for your plant life cycle as a whole, and not only on your daily activities. So it's, let's say, a general principle about the digital factory. It's a framework you can use to say, okay, I want to digitalize my plant, so I do it. And the second standard is here to tell you that, or you can make your measurement, or you can make your control, your automation, or you are going to build up, let's say, your communication process, or you are going to capitalize and explore your data to build up solution and stuff like that. So it's quite useful. And if you are really looking into leading yourself to digitalization, that might be the standard you might be refocusing on. Going on the next one here, it's about the architecture. Of course, the architecture of the data is quite important because it's not only a way to communicate it, you have to communicate it in a clear way, in a build-up way. So, for example, cloud receiving information from different plants and different machines can be sure that they can agglomerate your data between each other and build a complete view of the scope. And here, those standards are here to explain that. Of course, about batch, because we are not only, let's say, a process industry in the energy, we are really in the process, but you have a lot of factory and manufacturing, which is processing data information, not only in live, but also in batch. So that's quite a common misunderstanding that there is, where you start to mix information from manufacturing and process industry. So that's where we make the limit. Also about the safety, about measure controlment, to be sure that when you, for example, you want to measure temperature in a plant, you're sure that you measure the temperature in the same way in all the plant that you are looking. So this has to be aligned as well. That's the second. And also, you have to align the people on time, saying, okay, if you are measuring information in this way, at the beginning of your, let's say, life cycle of your plant, you have to be sure that it's consistent with the way someone is doing it on a plant that is 24 years old, because it might be a little bit different to do with all the, let's say, maintenance that you have been doing on your motors, for example, and stuff like that. So that's really trying to follow this life cycle. Then, of course, you have a topic on integration because it's quite important. The last slide about the detail really of those information is about cybersecurity. Here you might know, and as soon as you are working on digital project, that cybersecurity is always, let's say, a critical topic that you need to address. Not only on digital, but I mean on daily operation for your product internally, but also externally when you sell your service or your product to your clients, or to you when you start to work with your supply chain. And here you have two, let's say, main standards that are going to apply. It's quite important because they are really quite different in their nature. You have the series ISO 27000, which is not only one standard, but really a family of standards. You have the number 1, 2, 3, 4, and blah, blah, blah. And here the idea is really to talk about the information technology, the system of information you have implemented, and how you can implement on top of your security of your information system security. You have a certification for this ISO standard because it's a push organization to be better on a daily basis as soon as they face a problem, to handle it and have, let's say, a quality management to make their, let's say, information system right, updated, and more secure every day. The difference between this ISO and the following standard, the second one, is that the ISO doesn't put you a threshold of level of security you have to be. Let's say the ISO is more like a motor. It tells you to be better, but it doesn't put you a goal and a threshold for your certification. At the opposite, the IEC 62443 standard is to say it's a 4-layer standard to say, okay, if you want to be at this level of security, you have to achieve this level, and you have to put in place those security system. If you want to be at level 2, this is the over layer and over technology you have to put in place, and blah blah blah. And you have 4 levels there where you can be certificated for, and where you really have to implement the security to protect your organization, your product. It's also a certification that may apply to people, for experts worldwide known, and there are only few, unfortunately, but you can be certified yourself about this IEC. But that's really, let's say, an added value to say, okay, my product is secured, or my internal organization is secured at this level 1, 2, 3, and 4. In fact, to go to the conclusion, and I see the time is running already. The idea behind all this webinar today was first to send you the message that the digital standard have been existing for a while. They have been created from, let's say, a common need worldwide in the year 2014, 2016. And that's where the creation has started, but they are still, let's say, evolving today. Those digital standards are, let's say, for us, umbrella and group under this Industry 4.0 tag, because this Industry 4.0 initiative was created first as a technology enabler to go digital, and of course the standardization was the first common ground for everybody to go after it. So if you see Industry 4.0, it's not the standard itself, it's just the umbrella, let's say, that is grouping all the standards behind it. Then you have to understand that this Industry 4.0 is a tag, it's kind of a brand, but it's open, okay? It's nothing, let's say, private, it does not belong to a company, and it's in perpetual evolution, because as soon as new technology are evolving, then of course the standard has to adapt and has to catch up. Of course, the Industry 4.0 has a global recognition, as Jean-Charles was mentioning, and myself as well. You could see that many countries are involved. All the main, let's say, industrial countries around the world have been aligned on this Industry 4.0. And you have all the ISO committees around the world working on those standards, which are participating into this Industry 4.0 initiative. And of course, each standard industrial committee is also let's say, interacting with the Industry 4.0 Standardization Council, because as soon as people are starting to work on a standard, it may happen that they have, let's say, a border with the next, let's say, standard, or they start to grab and address topics which are already done in the next standard. So this, let's say, Standardization Council also has a job to make people collaborate and interact together, because one modification in one standard may have an impact on the other one, so it needs a lot of alignment, as you may understand. And of course, it's a huge job to do that, but it's very well maintained, and the community behind the standard and Industry 4.0 organization are really dynamic and active to make a system that works very well. Then just two points. First, on the cyber physical system, that's the enabler behind Industry 4.0. That's where we talk about digital twin. That's where we really try to create value over our equipment, because the industry manufacturing or process is all about making equipment run and operate. So that's why that's where the digitalization starts, and that's where let's say the Industry 4.0 starts as well, and the standardization started. And the last point, and which is not least, is to say the digitalization and the Industry 4.0 not only relies on technology, but also on standards. That's great to have all the technology behind, to have artificial intelligence, to have machine learning and stuff like that. But if you are not able to align yourself in a common standard, to be able to go out in this world, sell your solution and make your solution interact with others, there is no point in it. So there is the last message to you, and that's why we have named it International Standard for Digitalization, that this digitalization has already its own standard that you need to know if you want to take part of the race, because if you are not aligned with those standards, there is no way you can take the start of the race to either digitalize yourself or to either propose your solution for digitalization.